So now I am doing the next learning target, which is focused on pages 254 to 256. So I do want you to have your textbooks kind of open and handy so you can be looking along as I'm talking, just also because this in particular lesson has a lot with tables and kind of lengthy questions, and I'm cutting some corners and not wanting to rewrite everything on the whiteboard. So I'm hoping that you have your book handy to reference. So I'm actually right now on page 254, and this is called example number 3. And it says, so I'm reading from the book, that's why I'm looking down. The table shows the price, P dollars, for X cans of soup. P is directly proportional to X. So they're telling you it's directly proportional. I have taught you the way to also identify if something is directly proportional is to look if they can be made into equivalent ratios. So this one was 1 to 1.6. This one is 2 to 3.2. I'm just taking off the 0 because we don't really need it. And this one is 3 to 4.8, right? So for 3 cans of soup, it costs $4.80. For 2 cans of soup, this costs $3.20. For 1 can of soup, it's $1.60. And of course, 2 divided by 2 is 1, and 3.2 divided by 2 is 1.6. So of course, this does end up being able to be made into an equivalent ratio. But remember, the other day, there was one where the third one didn't work. So you always need to check all of them. So 3 goes into 3 once, and 3 goes into 4.8 1.6 times. So of course, this can be reduced to the ratio 1 to $1.60. So in fact, even if the book didn't tell you it was a direct proportion, you know how to do that. You should be, I kind of want you doing that right out of the gate, just evaluating in a table whether the X and Y represent equivalent ratios for each ordered pair. Okay, but they tell you that it's a direct proportion, so that's helpful. Thanks a lot. So it says find the constant of proportionality, because that's what this is representing, or this lesson is about, and then tell what the constant represents. So let me write, this is like a lot of things. So first, find the constant. Then it said tell what it represents. Represents. And then it said write I'm going to cheat here, direct proportion equation. So how would you tackle trying to find out what the constant is in this table? So of course, if you look over here, the things we need to keep in mind, if they don't tell you outright what the constant is, you can use the formula that the constant is equal to y divided by, I lost my cap, y divided by x. So I also had told you that in the tables, x is generally on top and y is underneath it. And that's, again, we end up talking about the independent variable and the dependent variable. So the number of cans that you buy is the independent, because the price, what you pay in total, is going to be dependent on how many cans you buy. So this is your X, and it tells you that this is your X actually in the book. And therefore, this means this is your Y. So they've told you it. I'm just also trying to help you reason why it is. But K equals Y over X. So in this example, K equals 1.6 divided by 1. In this example, K equals the Y, which is 3.2, divided by 2. In this example, the Y is 4.8 divided by the X, which is 3. And of course, if we do this out, well, we know this. K ends up being equal to 1.6. In this example, K ends up being equal to half of 3.2, of course, is 1.6, and a third of 4.8 is 1.6. So, in fact, we have found the constant. The first thing that we found is the constant, K, is equal to $1.60. So what does the constant mean here? What does it represent? The constant is representing how much the can one. I literally just threw my marker across the room. Sorry about that. The constant represents that your price, your total price, is going to go up by $1.60 for each can that you buy. So K is representing the price per can. Remember, we talked about K, the constant, is the unit rate, and here it's proving it. In this example, K represents the price per can. And when they give you the 1 as the X, I don't know if you have figured this out or not, but when they give you 1 as the X, right out of the gate, you're able to find the constant because it's whatever the price is divided by 1, and therefore you get the constant. But that only works if the X is 1. That's just a little secret. If the X is 1, it doesn't work if you don't start out with it being 1, because this is saying 1 can costs $1.60, 2 cans, $3.20, 3 cans, $4.80. I'm going to have you pause and just project and tell me, I'm adding this on, the book didn't tell you to do that. What do you think it would be if you had 5 cans? What do you think your Y would be if you had 5 cans? 5 cans with a constant or a unit rate of $1.60. What would that make your total cost? Pause. I'm back. Hopefully you said that at 5 cans, if that was my X, my Y would be 8, and that would be correct. 5 cans times a unit rate of $1.60 gives us $8. So we could project that if we were to buy 5 cans, we need to have at least $8 to be able to make the purchase. All right, so the constant represents the price per can, and then write a direct proportion equation. So remember, that's that equation which is Y equals K times X. So in this case, you're like, well, I know the constant's 1.6. Okay, my number of cans is the X variable, but in this case, they don't use Y, they use P. So in theory, like honestly, if you had written Y equals 1.6X, I would tell you to redo it because you are supposed to use the variables as they're presented to you in the problem. So the correct answer here would be P, because that's representing Y. P equals 1.6X. And in fact, in essence, this is saying the total price, right, P, the total price in dollars is equal to 1.6, my constant, my unit rate, my price per can, times how many cans that I buy. And that makes sense, right? Because the number of cans times the cost is going to give me the total cost. And this is my independent variable, and this is my dependent, because my total price is dependent on how many cans I buy. All right, now you're gonna try one on your own. Okay, so I am getting lazy here. I'm like just erasing words that I don't need. So I'm on page 255. And the skill here is recognizing or identifying a constant of proportionality in a verbal description. So there's no table or anything, it's a verbal description. And what we're really looking for is if you can identify the constant of proportionality or the unit rate in a verbal description. So Alice is buying some baseball caps. Each cap costs $8. The amount Alina, maybe I shouldn't have, I'm going to change her name to Alice. I like that better. The problem did say Alina, but Alice. The amount Alice pays for the cap is directly proportional to the number of caps that she buys. Write a direct proportion equation that represents the situation. So I'm going to ask you, I'm going to have you pause and see if you can identify the constant and what you think would be the X and the Y. So when I say what you think would be the X or the Y, remember X is the independent variable, right? The thing that stands on its own, and Y is the dependent variable. So in the last example that we did with cans, remember the total price that you paid was the Y, because the total price was dependent on how many cans you bought. In this case, can you identify the constant? Can you think which you think represents the X and which you think represents the Y with the words from the problem? So I'm going to have you pause. All right, we're going to be back, and hopefully you picked up on the fact that Alice is buying some baseball caps, and each cap costs $8. Each cap costs $8. Right there, I have my constant. I have my K is $8 because that is my unit rate. We've learned that language before. If it says each or per, it is telling you it is a unit rate, like heartbeat per minute, miles per gallon, dollars per pound, or each pound costs $2, or each gallon is 13 miles, or I can't remember what heartbeat. That one for my unit rate would be like each minute my heart beats 70 beats per minute, right? So each or per tells me it's a unit rate. So K is $8, that's my unit rate. Then hopefully you said the amount Alice pays for the cap is directly proportional to the number of caps she buys. So the amount she pays is directly proportional to the number of caps she buys. So remember, the amount she pays, that's the total amount she pays, that's your Y. Your Y equals total amount paid. And your X is represented by the number of caps, right? And that makes sense. That the number of caps times the unit rate is going to give me the total amount that she pays. So what the total amount she pays is dependent, it's a dependent variable, it is dependent on how many caps she buys at the rate of $8 per cap. So now it says write a direct proportion that represents the situation. Y equals 8X. That would be your answer, right? Y, the total cost that Alice pays, is a direct proportion relationship between $8, the price per cap, times how many caps that Alice buys. All right, I'm going to have you try one on your own. Okay, so we are now on page 256. Identify the constant of proportionality in an equation. So we've looked at how you identify constant in a table, right? We've looked at how you identify a constant in a verbal description, and now how you can identify a constant in an equation. So this is page 256, just the first example that they have. So Y is directly proportional to X. So in this case, they're telling you, so you don't have to do any of the things that I've shown you in terms of identifying that they have equivalent ratios, the X and the Y, in a table. In this, they're telling you Y is directly proportional to X. So that is a given. And when Y equals 3, and Y equals 3 when X equals 9. So if we had that kind of little table here, we would show X, right? And Y, and it's saying X is 9 when Y is 3, okay? So X is 9 when Y is 3. So find the constant of proportionality. So how do we find constant? Hopefully you remember. Wait, I didn't want to do that. Stop, pause, type in, what's the formula for finding a constant? Pause. All right. Hopefully, you said that the formula for finding a constant is that K equals Y over x. So we actually have the information that we need above, because it's already told us it's directly proportional, and it told us what our y is, and it told us what our x is. So k equals y over x, which in this example means that k is equal to y was 3, and x is 9. 3/9, which of course can be simplified. So k equals 1/3, because I divided by 3 on my numerator and my denominator. So we already found the constant of proportionality. Like, wasn't that super easy peasy? So the constant is 1/3, okay? Write a direct proportion equation. So now that we know that k equals 1/3, well, how do we write, what's the equation for a direct proportion? What's the formula for a direct proportion equation? I'm gonna have you type it into Edpuzzle, pause. All right, hopefully you said that the direct proportion equation is y equals k times x. So in this example, y equals 1/3 times x. With this information, I could fill in more of the table. So give me a value for x. Let's just say that I'm going to say x is equal to, I'm going to say 18. So if I plug in the value y equals 1/3 times 18, I should get that y equals 1 times 18 is 18. So 18/3, which means y is equal to 6. So put that there. All right, I'm going to now say x is equal to, let's just say 24. 1 times 24 is 24 over 3. In this case, y is equal, did I do that right? 3 goes into 24, 8. So 24, 8. And I could go down here and say, all right, I've got a 9:3 ratio. I've got an 18:6 ratio. I've got a 24:8 ratio. And I can simplify 18 divided by 2 is 9, and 6 divided by 2 is 3. And then, let's see, 24. Did I do something wrong there? Oh, I know what. I don't want to use 24. That's what I did wrong. Again, if we were in class, you guys would have told me. I picked the wrong multiple of 9. It's not 24, silly Mrs. Sayward. It's 27. That's why it was off. So let's fix that up. 1 times 27 is 27. 3 times 1 is 3. So y is equal to 9. That makes more sense. 27 and 9. And of course, that can be reduced down to 9 to 3. So this was added. It isn't even part of what the book's necessarily requiring you to know. But what I'm hoping that you're starting to see is just the relationships in a direct proportion. Once we had this formula, y equals 1/3 x, for this problem, I could go and fill in the rest of my table using this information. So the constant is going up 1/3, right? And you can see in the relationship here as well that we're seeing 9, 18, 27. And then at the same time, we're seeing 3, 6, and 9. Well, 3 is 1/3 of 9, right? 6 is 1/3 of 18. 9 is 1/3 of 27. That's why the constant 1/3 makes sense. Hopefully light bulbs are going off all over York with you guys, and you're starting to really feel positive about this concept. So you are going to try a couple on your own. All right, bye.